Constraints is also one of these essential rigging features, and it's very similar to how parenting works in some ways and very different in other ways. In the last chapter, when we covered parenting, we actually control one object with another through the hierarchy. But we can also do it without a hierarchy. We can use constraints to make one object affect another object. We have to switch the mode to rigging, and under constraints we have a bunch of different constraints. We can also access this with Hotbox by holding down the spacebar, and we have constraints right here. This is actually my preferred way of doing it. I use constraints. I use the Hotbox for constraints, and I use it for the blend shape modifier or deformer for some reason. That's just completely personal preference, but you can find the exact same menu, spacebar, constraints, and constraints up here. The first one we have is the parent constraint. This will be almost exactly the same as actual parenting, but we are using constraint. One of the differences is that the selection order is different. Before we selected the slave, then the master. Now we will select the master, then the slave. Like I said, Maya is a bit picky when it comes to its selection orders, and it's different for different things. We, of course, have outlined this in the PDF because this gets confusing, and I just know this because I've been doing it so many times. It's more muscle memory, but I still screw this up occasionally. I've seen super senior riggers who still mess up selection order. It's not you, it's just Maya. The selection order is master and slave. So we can select master, which is, well, it's named master to keep it simple. Then we click on the shift click on the slave, and then we hit parent. And now you can see that we have added a parent constraint under the shape. If we expand the slave in the outliner, we can see that we now have a slave parent constraint. Again, just a node which has been added. What happens now if we try to move the master around is that it will do the same as it did with actual parenting it. But now you can see that this has nothing to do with in terms of the hierarchy. We can completely unparent this and it will be in a completely different area. And this doesn't matter at all. It will still move it around. It will still rotate it, but it will not scale it. So that's the primary difference between parenting and constraining, is that parent constraints will not scale your object. So let's just put this back in here. The way we can delete a constraint is by selecting it in the outliner and simply hitting delete. And now it's back to where it was and it's not affecting it at all. Then we have point constraint. The point constraint will constrain this object to that object, but only through translation, meaning if you move it, it's going to work, but if you rotate or scale it, it's not going to work. So select the master, then the slave, and when we click it now, something weird is going to happen. And I can see that it actually moves it to the actual center of the object where the pivot is. This can be fantastic. Some people use this for actually aligning objects. They select one, select the other, do a point constraint, and it will just snap together. That's a nice little tip. But it's not what we want, because you can see it actually moves back. Let's undo that, and let's look into the options. The important option here is maintain offset. If we enable this, now you can see that the offset has been maintained, and if we move this around, it's going to respect the translation. But if we rotate it, nothing is going to happen. And if we scale it, also nothing is going to happen. So this can be really handy in certain cases in rigs where you only want to get the actual translation values. Back again here, under the slave, and delete it. We can just reset the translation. Reset rotation as well. Then we have the orient constraint, which would operate in the exact same way. Select master, select the slave, and then we hit orient. And in this case, it's not going to snap back because it doesn't actually affect the position. But if we were to undo this, and then we have rotation on this. Select the master, select the slave, orient. Now you can see it actually resets the orientation to what we had. So if we have orientation on it, now yet again we have to go under the options, click maintain offset, and then it will maintain the offset. Now if we rotate our original cube, it will translate these values to the torus. Do the same again, delete it. And when we delete it, it will just reset. It won't reset any translation values or any values whatsoever. It will only delete the constraint. So the position will be exactly where it was before. So let's just go in and reset the rotation values. Simply just drag over it and hit 0. That's a very easy way of doing it. Then we have a scale constraint, which will do exactly what you expect it to do. It will scale the object. Select one, select the other, with scale. And again, because we don't have maintain offset selected, it will inherit scale values from the cube onto the torus. So with all of these, it's important that we enable maintain offset unless you don't want it. Unless for some reason you really want it to be exactly the same. And now we can scale up, but it doesn't get the translation. So what you can do if you want to have the exact same experience as you do with actual parenting, you could select the master, select the slave, do a parent constraint. Then you can select the master, select the slave, and then we can do a scale constraint. And now you have a parent and a scale. And if you move it around, it's going to work. If you rotate, it's going to work. And if you were to scale it, it's also going to scale it up and down. What some people prefer to do is that they use, instead of a parent and a scale, they use a point, an orient, and a scale constraint, which gives you a bit more freedom because now you can disable each one of them individually. One which is really cool as well is the aim constraint. So if we hide these two, and here we have a super quick eye model I've just created. What we can do now is we can make the eye follow this. So let's say you have a rig and you want to move the eyes around. You're not moving the eyes around, but simply just rotating it around. That's incredibly hard. You need to be able to control the eye so you can really control where the character is looking. Let's say you want the character to look at this exact point over here, right here. Instead of rotating around and hoping that you kind of hit the point, what you can do, you can constrain it to an object, and then we can move this point to exactly where you want the character to look. The way we do this is we use a point or an aim constraint, and we use an aim target as well. Now, this doesn't have to be a cube. This can also be a NURBS curve. This is what you would often do. In this case, we're just using a simple cube just because it's easy to understand. But if you're actually in a production, you would most likely be dealing with a NURBS primitive, and you'll be using a NURBS circle. The reason you'll be using a NURBS circle is because this will not render. In this case, this will actually render. So you would have this weird cube in front of the character all times, and people are wondering, what is that? Or you have to turn on the renderability, and that's why we use a NURBS circle. The way we activate the aim constraint is we first select the master, then the slave. This is the same with every single constraint. Now, you might be wondering, why am I selecting this first and not this? Well, we want this cube to control the eye. So first we select this, because this is the master, then we select the slave, and then we click aim constraint. Again, we have maintain offset enabled. If we don't have maintain offset, it's going to rotate in a weird way. So make sure you have maintain offset enabled. And now we can start to move this around. And now you can see how incredibly precise movements you're getting with this. If you undo this, and we have another eye, just shift drag to clone it. We can move this in between them. And then we can make both the eyes follow this. So select the cube, select one of the eyes, and then we can do an aim constraint. Select the cube, select the other eye, do an aim constraint. Now you can see they're both following along based on this. This is incredibly handy for all sorts of things. This is not just used for eyes, though it is always used for eyes. But you can use this for, let's say it's a sentry gun, which is targeting the player in a game, whatever it might be. It's a light which follows a character along. This is used for all sorts of things, and this is a really awesome one. It's also one of the most fun ones just to play around with, because now you can just make the eyes follow along. And again, in order to delete the constraint, we simply delete the constraint. We select the constraint and we simply just delete it. And now you can see both of them are following this exact point. Now let's hide this and let's go back to our trusted arm. In the last video, we used parenting, direct parenting for this, but in this case, we can also use parent constraints for this. The advantage again of using parent constraints in something like a rig is that you are not dependent on the hierarchy. You can have a model which is far away actually impact a model which is in a completely different group in a completely different part of the scene. Let's say you have a boulder falling down from a cliff and you want that to impact a car somehow. You don't actually have to put them in the same hierarchy. You can just have a boulder group, you can have a car group, and now you can parent or you can constrain them together. So the way we do it now is almost the exact same way as we did before. The only difference now is that we have the reverse selection order. So select the master, then the slave, then we hit parent, master, slave, and instead of hitting parent, we're going to hit the G key. Now you can see result, hand parent constraint 1. And again, remember G just repeats the last action. We can select the hand, select the thumb, select the hand, select the finger, and the G. And now you can see that all of these now have a constraint attached to them. So if we now were to rotate this around, you can see that this now rotates perfectly, exactly the same way as before. The only difference is that it's not going to scale it. So if we scale this crazy up and down, it's not going to work. If you want to scale it, you have to enable a scale constraint as well. But in a character rig like this, you really don't want to scale your characters up and down. You want to make sure you have the scale before that. But if you do have to scale it, if you do have to make your rig scalable, then you will use a scale constraint for that. So constraints is a really powerful method of rigging, of making one object affect another object without it being tied to a hierarchy.